Today topic we are going to discuss about pressure measurement using U-tube manometer. What is pressure? You all know about pressure. Pressure, which is nothing but force divided by unit area. The pressure can measure using various units which are called as a Newton per meter square, then bar, Pascal. There are so many units. There are 4 units we have to measure pressure. So when you are talking on the pressure measurement, there are 3 pressure we used to call absolute pressure, gauge pressure, vacuum pressure. Absolute pressure, which is nothing but the absolute value of the force per unit area exerted on the containing wall by a fluid. So atmospheric pressure, which is also called it as a barometric pressure, and which is nothing but the weight of the air in the atmosphere. Gauge pressure, which is nothing but difference between absolute and atmospheric. So what is the meaning of absolute? Absolute, which is nothing but the absolute vacuum, that is 0. So gauge pressure we can measure through the difference between absolute and atmospheric pressure. So what is vacuum? Vacuum, which is represent the amount by which the atmospheric pressure exceeds the absolute. The vacuum may not be greater than the local atmospheric pressure. So these are all the different types of pressure measurement we have. What are the common units? 1 atmosphere, which is equal to 14.696 pounds per square inch. That is usually called PSI, pounds per square inch. So in terms of Newton per square meter, PA, which is nothing but Pascal. The same thing we can call it as LPF, bar feet square. That is nothing but pounds force per square foot. Then 1 Newton per meter square, which is nothing but 1 Pascal. So 1 atmosphere generally the value is 760 millimeter of mercury. So 1 bar, which is nothing but 100 kilo Pascal. So this is how the common units of pressure measurement they are using. So when you are looking at the diagram, it is like a U shape. That is the reason why this is called as an U-tube manometer. So the simplest form of manometer, which consists of an U-shaped glass tube containing a liquid. So when you are looking at here, the tube which is the shape of U shape, that is the reason it is called U-tube. And mano, which is very minute, and the word is Greek word mano, and manometer is a device which has an U-tube shape. That is the reason it is called it as an U-shape manometer. And particularly this meter, that is U-tube manometer, are used to measure a very low pressure measurement, and it is used to measure the gauge pressure. So gauge pressure, which is nothing but the difference between absolute and atmospheric pressure. And we had a previous class the discussion on elastic transducer. The elastic transducers are used for the measurement of medium and high pressure measurement. So for high pressure measurement, we have 3 devices in the previous class. We had a discussion, that is bellows, go down tube and diaphragm. So these are all the devices for medium as well as high pressure measurement. For manometer, it is in low pressure measurement. Then for vacuum pressure measurement, there are 2 devices. One is called McLeod gauge. The another one is called thermal conductivity vacuum pressure measurement. And this U-tube manometer, in the center part, you have a scale, mirrored scale, through which you can able to calculate the value. And the height of the liquid, and the bottom there is a dotted line. These lines are usually called it as an datum line. The datum line, which is nothing but the equilibrium portion of the particular tube. And there are left as well as right. There are two tubes, and they used to call it as an limbs, or they used to call it as an legs, right leg and left leg. So when you are looking at the diagram, the left one which is pressure to be measured, the right one which is nothing but atmospheric pressure. So the atmospheric pressure which is a reference pressure. So the unknown pressure which is nothing but your left side. And this instrument is primarily instrument which is used in the workshop for the calibration for differential pressure measurement. So differential pressure measurement, they used to have the term which is called delta H. Delta H which is nothing but the difference between two pressure on both the limbs. So the principal manometer which is nothing but the pressure to be measured is applied on your left side of the tube. It produces the movement of the liquid. So what will happen when the liquid is passing through the left limb, automatically there will be a variation on your manometric fluid. The manometric fluid which is nothing but mercury, then we have in water. So the level of the filling liquid in the leg where the pressure is applied, automatically the left leg of the tube has dropped while in the right hand leg has risen, and the scale is fitted on the center portion through which we can able to identify how much displacement is taken place. So the pressure we are measuring have applied to the left hand side of the manometer of constant value, and the liquid will only stop when the pressure is exerted by the column of the liquid. So there should be a balance on the pressure applied to the left side of the manometer, and the applied pressure which is known as P, which is equal to rho GH. So H is in height of liquid, rho is in density of liquid, and G is in specific gravity. So the manometer liquids and their densities are generally they used water, oil and mercury. So water which is the value is 1000 kilogram per meter cube, oil it is 950 kilogram meter per minus 3, and mercury which consists of 13560. So when you are looking at here, I have given three diagrams. The first diagram which is nothing but you have the liquid level is at the equilibrium, that is nothing but the balanced position. So I am just going to apply the pressure of the liquid on the left side. That is what my second diagram. The second diagram, when I am applying a pressure on the left limb, what will happen? It will push down the liquid which was present inside the tube. So automatically there will be a rise in the left side, right side. The third diagram, when you are looking, I am just going to apply a vacuum on the left side. So automatically the sucking will be happen. So the rise will be happen on your left side comparative with your right part. So these are the three operations normally performed in your U-tube manometer. So this is the basic structure they have used. So when you are looking at the diagram, only the tube sections over there, it was not connected with the liquid passing. So the next diagram you can just look at here. There is a circle that is nothing but your liquid path. The liquid path which has been connected with your U-tube manometer, and your right side one more circle point over there. So here this PA which is nothing but the pressure what we are going to measure, the pressure of the liquid. That means unknown pressure of the liquid. That is what the indication of your left limb. The right limb, when you are looking, it is nothing but your reference pressure what we have, that is nothing but your atmospheric pressure. So when the unknown pressure is applied, automatically the red line there will be a variation. So it will pull down, the red line will go upper. This is how when you are going to the industry, this is how the U-tube you can able to see. It's not an open. The previous diagram what I have shown is both the limbs, that is your right limb as well as left limb, both are open. But here it's not so. It is not open. There is a closed chamber. In the left path, you have it's connected through your pipeline. The right side also it is connected to the pipeline. So both are closed. The next one, when you are looking at here, we are just going to do some derivation part. That is the reason I have given this particular diagram over there. So when you are looking at the diagram, the first one is your unknown pressure. So what does it mean, unknown pressure? I have given the indication is P1. The reference pressure, which is nothing but your P2. And the height of the liquid of your pressure, which is unknown, it is H1. And the variation is going to happen, that is your H2. It is referred with your reference point towards your manometric fluid, that is H2. And del height is the difference between the datum line and the rising part. And W2 is specific weight of the reference pressure or if of your right limb. Then Wm, which is nothing but the specific weight of the manometric liquid. So in the diagram, the upper portion, there are three things I have given. That's what I already explained to you. The equal balance. Then the second one, next one is about your absolute. That is nothing but when the unknown pressure is exerted over, then automatically there will be a rise. And the third one is your vacuum. So the second one is positive pressure and the vacuum one is negative pressure. So that is how it differs. So we'll see the derivation part. So your manometer is generally operates on the principle of hydrostatic balance, where it includes reservoir and it is filled with a liquid. And the reservoir is usually enclosed with a connection point and it can be attached to a source to measure the pressure. So it consists of a transparent tube, that is what your U-tube, and they used to call it as a column, and it is also attached to the reservoir, and because of the shape it is U, it is called U-tube manometer. So when you are looking at this, the advantages of U-tube manometer, it is very simple in construction and low cost, easy to buy. It is very accurate and sensitive. It can also use to measure other process variable. The disadvantages of this U-tube manometers, it is fragile in construction and it is very insensitive to temperature changes. So what are all the applications we have in U-tube manometer? The application is very important thing is it's used for measuring a very low range pressure measurement, and it is extensively used in laboratory for calibration point. So generally when you are looking at in the college, in physics laboratory, you have noticed U-tube manometer. Not only that, you would have gone some practical lab also. The same operation it performs. The third one is the application is the U-tube manometer, which was inserted in the path of orifice meter and the venturi meter for flow measurement. So the orifice and the venturi meter is a device used for measuring the flow. So when the flow measurements, if the pressure level is not noticed, then there will be a biggest problem. So the pressure measurement is very much needed for the flow path. So that can be measured via orifice and the venturi. So in the construction point of orifice and the venturi, they had an U-tube manometer. The next application is it's used for calibration of gauges and for other instrument. So U-tube manometer is a calibration instrument. Calibration means it is nothing but the unknown value which is compared with a known standard. That is what your calibration talks about. And also it is used for measuring a pressure drop at a different joints as well as valves, whatever the valves you are going to use it in the industry. So when you are coming to this U-tube manometer, the derivation part is going to be my part 2. So please have a look on your part 2. It is very much needed for the derivation point of view of your U-tube manometer. So conclude of this particular thing is just we had a discussion on the construction, then principle, then how the working and advantage and the disadvantages. So the second part it is going to be the derivation part of your U-tube manometer. Thank you.